So, okay. So the first thing we're going to go over today is multi-step equations. And if you'll remember, multi-step equations are a extension of simple equations. A simple equation looked like this. Are you in the meeting? Can you see? Can you join the Teams meeting just so that way you can like see what I'm writing? Because okay. Do you want to come up here so that way you can see while it's preparing? Just so that way you can see what I'm writing.
Yeah.
Okay, so a simple equation looks something like this. 2 minus x equals y. And when we go to solve for something like that, we I'm sorry. We don't need the equals y. We need equals something like 4. So when we go to solve for something like this, we subtract our 2 across. We're trying to get our x by itself. And this will cancel out. So we end up with a 2 here and a negative x over here. So to get rid of this negative, we divide by -1, because really this is a -1 right here. So when we divide by -1, these will cancel, and we will get -2 over 1. And anything over 1 is the same thing as just the thing. So really we just get -2. So that's a simple equation. They do get more complicated with multi-step equations. And multi-step equations look something like this. 4m minus 8 equals 12. So with a multi-step equation, we solve it the same way. We're trying to get the variable by itself. So we add 8, and that cancels that out. And then we are left with, we add 8 over here as well, because anything we do to one side of the equal sign, we have to do. So we get 20. We end up with 4m over here. And now we get m by itself. So we divide, and we get m equals 5. So it's a process of just getting the variable by itself. It's just a little longer because we have to do division, multiplication, things like that. Make sense?
Mm-hmm.
Make sense, virtual people?
Yes, sir.
Okay. Another type of problem that we can deal with multi-step equations are something like this. X over 7 plus 5 equals 32. And this is okay. It's a fraction, but if fractions don't scare you, then you're in the right spot. So we still deal with this by itself. We go backwards in our order of operations, if you'll remember. So we undo addition and subtraction first. So minus 5, minus 5. So we end up with 27. And now we end up with x over 7 on this side. So to undo a fraction, we multiply, and we multiply what's on the bottom. So when we multiply by 7, we multiply by 7, and 27 times 7 is 189. So we've got x completely by itself, and we have solved our multi-step equation. Sometimes these will look like bigger problems, such as if we end up with 2x plus 4x minus 17 equals 4. And this looks bigger, but really all we have to do is add these together. We add our 2 and our 4 together and we get 6x because we're counting x's. And then we end up with 17 because it doesn't have an x beside it, so we can't combine it with 6. And we equal 4. And then this is something that we know how to do already. We add our 17 across, and we end up with 21 equals 6x. Now we divide by our 6 to undo it. These will cancel. And we end up with 21 over 6, which doesn't divide, I don't think. Yeah, it's 3.5. So I'm just going to leave it as 21 over 6. So for virtual people, I'm going to move just so that way it's a little easier for my in-person person. So give me 1 second. I'm going to mute it. Okay. So moving on, we'll do another multi-step with a distribution property. So the distribution property is this. 2x plus 4 plus 4x equals 7. So what we do with our distribution is it looks like this when you have a number or something multiplied by a set of parentheses with more than one term in it. And with distribution, you take and you multiply it inside. So you multiply it by each piece of the inside. So we do 2 times x plus, that comes from right here, 2 times 4. And I'm going to leave this out of parentheses because we've done what we need to do with the parentheses. We can't add x and 4. So when we multiplied this in right here, we kind of did what the parentheses were there to do. So now we do plus 4x equals 7. So now we can solve each of these by themselves. We end up with 2x, no simpler way to write that, plus 8 plus 4x equals 7. So now we can combine like terms. We're looking at our x's, we're looking at our not x's, and that's all we have on that side. So we combine them. We end up with 6x plus 8 equals 7. So now we subtract our 8 across because, again, this is something that we know how to handle. We get 0 right there. -1 equals 6x. So now we divide by 6, divide by 6, and that will give us x equals -1/6. Or what is it? 1/6 is 0.166666, so on and so forth. Give me 1 second, guys. Okay, so does this make sense, the multi-step equation section so far for everybody?
Yes, sir.
Okay, awesome. Then let's move on to special equations. So special equations are, they look a lot like multi-step equations, but they want different information at the end. So we really have three cases with equations. We can end up with something that doesn't cross, something that crosses once, or we can have infinitely many crosses. And this probably sounds like Greek to you, and that's okay, because I haven't explained it yet. So when we end up with something like 3 equals 4, something that is just not true, that is something that never crosses. And we'll see an example of this in a little bit. Just know that when you find something at the end of it that doesn't make sense or isn't correct, it's case 1. With case 2, we could end up with x equals 4. And that means that at 4, that's when it crosses. And infinitely many crosses will end up with something that is true all the time. 4 equals 4, x equals x, 1 equals 1, something like that. It's kind of the opposite of the doesn't cross section. The crosses once is probably what you're going to see a lot going forward, but the other two cases do exist. And so let's work an example and maybe get down to one of these cases. So 2x plus 5 equals 5x minus 7 minus 3x. So this looks longer and bigger than any of the multi-step equations that we've done so far. But really what it is it's two different sets. So if we divide it in half, each of these sections looks like one of them that we have done before. So by dividing it in half, now we can work it independently. So we're going to work the right side because it's the most complicated right now. So we're going to distribute in. We're going to end up with 5x minus 35 minus 3x. Because I multiplied 5 times x, then I multiplied 5 times 7. And then I dropped my parentheses, and then we were left with 3x. So 5x minus 3x is going to give me 2x minus 35. So now we have these as simple as they can be on each side. 2x plus 5 equals 2x minus 35. So I'm erasing this just to make it a little clearer. Okay, so now from this point, we're trying to get x by itself. So we move all our x's to one side and everything else to the other side. So I'm going to subtract this 2x across and bring it over here. So this is going to cancel out. And I'm going to end up with 0x, or just anything multiplied by 0 is 0. So just 0 right here. Plus 5 equals negative 35. And if you take 0 and you add 5, you just get 5. So really what we have is 5 equals 35. So we look back up here at our cases and we say, okay, what about these lines? Because each of these can be drawn as a line on a graph. And what happens to them when we graph them? Do they cross? Do they not cross? Are they the same line? Which is our third case here. So in this case, it is our first case. They do not cross because we have things that are not equal. So if you were to put this into the GeoGebra calculator or one of the other online calculators that will show you the lines, then you'll see that these two lines are separate. They never get close to one another. Let's work another example, and then we will talk about it a little more. Good. Okay, so let's talk about 5x plus 2 equals 7x plus 1 minus 4. So this is the same type of thing. We just deal with them separately on each side. So we do our little distribution. We multiply this 7 to the inside. 7x plus 7 minus 4. So now we combine our like terms, our 7 and our minus 4. So 7x plus 3, 5x plus 2. So now we're doing the same thing. We're trying to get all the x's on one side and everything else on the other side. So I'm going to subtract this 7 across because I like my x's on my left side. These are going to cancel out. End up with negative 2x plus 2. This just comes down. So over here, we still have 3. So now we can move our 2 over here. So minus 2x equals whatever this is, which is going to be 1. So now we have our x's on one side, but it's not by itself still. We still have to undo this multiplication. So we're going to divide by negative 2. And we are going to get x equals negative 1/2. So now that we have this, we can look back at our cases up here. And we can see that this fits in case 2 because it looks something like this. It's x equals some number. So these cross one time. So if we were to graph them, I'm going to graph these, and you guys don't really need to worry about how. That's not really part of it, just to prove it to you that they do only cross one time. So, okay, so this is one of our lines. It goes through both of those points. There we go. And then to come. Okay. So clearly, if I had drawn these lines correctly, they would cross right here at the top, and then they would never touch again. Just like that. And so they cross at what we determined was x equals 1/2 right here. So this is, if I draw my lines correctly, this should be at exactly the 1/2 mark. It's not because, I'm not a great drawer, but that's where it is in reality if I had drawn these lines perfectly. So does this make sense so far about the crosses once, doesn't cross, so on and so forth? Okay. So I'm going to work a few more multi-step equations, and we'll talk about them when we get to the end of them. So okay, so now we can't work anything on the left or on the right side here. We can't add our 3x and our 16. So we're going to work on the left side. So we're going to do our distribution property, and we're going to multiply inside. So we're going to end up with 3x plus 12 plus 4. And 3x plus 12 plus 4, 3x plus 16, 3x plus 16. So they're the same, and we'll see what that means in just a second. So we're going to subtract negative 16, or subtract 16, and these are both going to cancel out. They're just going to equal 0. So now we have a 0 over here, and 3x equals 3x. So when we subtract this, this is going to cancel, and this is going to cancel too. So we're just going to be left with 0 equals 0, which it's a number equaling a number. That's true all the time. So we scroll back up and we look and we see that case fits right here. It is 4x equals 4. When you have one thing that equals the exact same thing, you can automatically just say it's infinitely many solutions. It will work every time for infinitely many. So that is one of those cases that you're going to run across sometimes. Why don't you guys give it a shot on this one, and we'll see what you got at the end. Give that one a shot, and in a few minutes, I'll check back with you and see how you did. Okay, what did we get? Or are we not done? Okay, I'll give it another minute. How about now? Anybody?
I think I got it wrong because does 2 over the 2 parentheses 17 minus x. But I got 40 over 6.
40 over 6. What on the other side of the equals sign?
6x over 6.
Okay, so let's work it and check. So what we're going to do first, I'm going to work from left to right. So I'm going to do my distribution. And when we multiply this times this, all we do is we multiply our number by our number, and we leave our x there. So 6x minus 12 equals, now we deal with the right side of the equation. So I'm going to distribute again. And there's a shortcut for this that I'll show you at the end that you're going to be mad that you didn't see. So 2 times 17 is 34. Minus 12, because it's 2 times 6. So now I'm going to add these together, my 34 and my 12. So 34 minus 12 gives me 22. So now we have 6x minus 12 equals 22. So I'm going to leave my x on the left side, and I'm going to move everything else to the right side. I'm going to do that by adding. This cancels out, and we end up with 34 over here. 6x, so now we divide by 6. So x equals 34 divided by 6, which I know will simplify. 5, I believe it's 5.3, I think. 5.6, I'm sorry. So all this little line means is that it just keeps going with the 6's. So we found 5.66 or 34 over 6, either one. They're both correct. So if we look at this and we go back and we say, okay, which case is this? Oh, we scroll back up and we have x equals some number. So we're dealing with case 2 here. It crosses one time. So how do you guys feel about that? Good, bad, ugly?
I feel a little bit better because I know where I messed up on the time where I tried to do this.
Okay. Well, we'll work another one or two, if that's okay. And then we will let you guys start working on your homework for this section. Or your just schoolwork, I guess. Your work, whatever. You know what I'm talking about. Okay, so let's do 4x plus 4x plus 3 equals 7x plus 3 times x plus 2. So give this one a shot, and we'll talk about it when you're finished.
Mr. Albright,
What's up?
is Mrs. Ellis around you?
She is not. She's in the other room. She's on the other side of the building.
Let me dial her extension real quick.
Okay. Okay, so I'm going to work through this problem, and hopefully you got what I got. If you see a mistake that you've made, maybe you can correct it. So let's get started. So on the left here, we start using our distribution property again. We end up with 4x plus 16x plus 3. And here's another way you could do that, actually. You could realize that on the inside, x plus 4x, we can just go ahead and work these and end up with 5x times 4. So 5x on the inside times 4, and we're going to get the same thing either way. It's just it may make it a little shorter if you want to do it that way. This way still works the same, and since we're practicing the distribution property, I'm going to keep it this way, but just know that you can go the other way if you want to. So when we multiply in, we get 4x plus 16x plus 3. So we get 20x plus 3. That's as simple as we can make it because we can't combine our x's and our not x's. Equals 7x plus 3x plus 2. I just brought it down. So now we do our distribution over here. So 7x plus 3x plus 6. Because I multiplied my 3 by my x, and I got 3x, and I multiplied by 3 by my 2, and I got 6. So now we combine them, and we get 10x plus 6 equals 20x plus 3. Just brought it down. So now we start solving. So I'm going to subtract 3, and I'm just going to move it to my right side. So I end up with 3 over here, 10x plus 3. So now I subtract my 10x. So I end up with 10x over here and 3 over here. So 10x equals 3. I divide by 10, divide by 10. These will cancel, and I will end up x equals 3/10, or x equals 0.3. They're the same thing. So this is definitely going to be in our crosses once case. If we look at it, we see x equals some number is crosses one time. So like I said, this is probably going to be the one that you run into the most often. So just be aware that this is probably what you're going to see. So guys, I think that is all I have for y'all today. So I'm going to let you go, and y'all have a good Friday and a good weekend, and I'll see you on Monday.
Thank you.
You
See you
too.
Monday.
Bye-bye.
Bye.
Bye-bye.